and if all goes well, they'll be available on our YouTube channel. So the lectures themselves. So theological education initiative and the things that we do, as long as we can get everything coordinated, I never promise, but hope. So that those should be available for you and your friends in the future. What I want to do just for a brief time is I just want to run through the books that you've written with just 2 and 3 sentences so that they know what to access particular to the subject. So let's take maybe the top 7, 10, depending on how quickly we can do it.
Yeah, well, you've heard about our testable biblical creation model. Where we present that is through many of our books. And so you already heard about the book Origins of Life. That kind of gives that piece of the testable model. Probably the best-selling book I've ever written is called The Creator of the Cosmos. It's now in the 4th edition. Say, why 4 editions? Well, every few years it goes by, the evidence accumulates. And with several of our books, you see this pattern of multiple editions, basically making a point that, hey, if you look at the 4 different editions, you see how dramatically the evidence has gotten stronger over the years. And so I tell people, keep the old editions, compare with a new edition, and use that as a witnessing tool.
The way the universe is the way it is?
Yeah, why the universe is the way it is. We wrote that at a lay level. I mean, some of our books are basically, I mean, people joke with me and say, hey, Hugh, a third of your book is citations to the literature. And that's because we want the book to have credibility at the top academic level. But thanks to my wife, if you skip the endnotes, it's written in a manner that everybody can understand. But why the universe is the way it is really explains why the physics of the universe is the way it is, why the universe has a characteristic the way it is, not just to provide us with a home in which we can live, but to prepare us for the new creation. And I look at that as the book that really answers the problem. If there's an all-powerful, all-loving God, why is there evil and suffering? Basically making a point, the entire universe was designed to eradicate evil and suffering once and for all. So explain why you have Jesus saying, in this world you will have tribulation. I like to paraphrase that. In this world you'll have thermodynamics. And the reason you need thermodynamics and gravity, electromagnetism, and 4 space-time dimensions, that's the most efficient way to eradicate evil in a quick period of time, in a way where we don't have to suffer that much.
Love that book. Always Be Ready.
Always Be Ready is a relatively recent book we put together, telling the story of how if you'll put into practice in your life, 1 Peter 3:15, you'll see God doing amazing, miraculous things. The book of Acts is not finished. I don't hold to the theology that all ended with Acts 28. It continues to this very day. If you'll do what you saw the disciples doing in the book of Acts, you'll have the same experiences. I told stories yesterday about, when we go out and share our faith, you see these things that are clearly God divinely and miraculously intervening. I wrote the book with a motive. I want every Christian to have these experiences.
All right, 2 other books that you want to name?
2 other books, so I already named More Than a Theory, which kind of gives you a survey of our testable creation model, but it's actually designed to get you deeper into it. My most recent book was Weathering Climate Change. Built on the biblical principle, we humans are fundamentally selfish. Trying to motivate people to solve the climate problem by draconian economic sacrifices won't work. But the Bible also talks about another principle, where God says to Adam and Eve, I'm putting you in charge of planet Earth. You're to manage it and manage its resources for your benefit and the benefit of all their life, which means that God has already provided us with solutions on this planet where we can resolve climate change, increase our economic well-being, and increase the quality of the world's ecosystems. Win-win-win solutions are available. People call my book the anti-Al Gore book, because rather than calling for economic sacrifices, I'm saying, here's a way that you can actually get an economic return. And I believe if you can show people where you get a 10% return on your investment or more, they'll do it tomorrow.
And I don't want to give it away, but drink more milk and eat more ostrich. So anyway, Grab the book, 30%. Another one you want to mention?
Well, another one I want to mention is the one that's going to be coming out in a few months. It's called Design to the Core. And I'm actually going to give you a little bit of a highlight of that in my closing talk here. Just showing you how literally everything in the universe, every component of the universe, every event in the universe, Earth and Earth's life, plays a role in making possible the redemption of billions of human beings. God not only designed the universe to provide us with a home, he designed the universe for redemption. And I've been telling my scientist peers who are not yet believers, if you will do your science research from a biblical redemptive perspective, it'll make you a more successful scientist. And I'm kind of doing that to get them thinking, gee, maybe I need to look at the Bible because it is making me a better scientist.
That's great. All right. Do you have a timer or a clock on you or anything?
I have a clock right here.
Very good. Okay. So 12:10 is when we're going to start our affirmations. And then if we could have about 30 minutes, maybe 35, I'll let you be the judge. I don't want to control it. But anyway, we want to do a Q&R still. So prepare your questions and affirmations. And I basically sort of laid a gauntlet down and I said, hey, what are the newest discoveries that you're excited about that have happened in the last year? And you said, hey, I'm the GOAT. I'm the greatest of all time scientist and I can handle you, Rod. Or something like that. That's how I recall it.
Well,
You Ross, everybody.
I've heard goat used in a different context. So.
You didn't know what it meant.
All right. Well, just a reminder once again that if you go to reasons.org and you put in TEI 2021, that's your gateway for a 30% discount on all of our products, not just for books, but literally everything. Well, I want to begin with a discovery made almost 2 years ago, but it really gives an example of how the more we learn about the book of nature and the book of scripture, the stronger case we get that God inspired both of them. And I'm going to begin with Genesis 1:14. And this is the passage where it says, let there be lights in the sky. And I believe that it says, let there be. This is not when God creates light. He created light in the beginning. In the beginning, God created the heavens and the earth. And then it says, let there be light. That's when light appears on the surface of the earth. But in creation day 4, creatures on the surface of the earth for the first time can see the objects that are responsible for the light. I've gone into this in detail in my book, Navigating Genesis, how you interpret Genesis. Genesis 1:2. The Spirit of God is hovering over the surface of the waters of planet Earth. That's the frame of reference to interpret the 6 creation days. It was Galileo who said the biggest mistake you can make in Bible interpretation is to get the wrong point of view. The reason why so many scientists think Genesis teaches scientific nonsense, they interpret Genesis 1 as if God is above the earth, above the atmosphere, above the clouds. And from that point of view, everything is scientifically wrong. But the text says the Spirit of God is on the surface of the waters. And what does it say? It's dark on the surface of the waters. You go to Job 38, a parallel text to Genesis 1, verses 8 and 9. It says, God blanketed the seas with clouds that kept the seas dark. It's dark because the earthy atmosphere of the earth would not allow the passage of visible light. I was 17 when I first read Genesis chapter 1, but I've been studying astronomy since I was 7. And I knew the planets the size of the earth must begin with an atmosphere about 200 times thicker than what the earth has today. An atmosphere that thick will not let any visible light through. With Venus, for example, it has an atmosphere 90 times thicker than ours. The only light that gets through in the visible part of the spectrum is the far red end. Everything else is blocked out. But on creation day 4 is when the atmosphere goes from translucent, which means completely hazed out, where it becomes transparent. And what we now know is that oxygen plays a critical role. And this graph here shows you the oxygenation history of planet Earth. Where for the first couple of billion years, you got way less than 1% oxygen in the atmosphere. In fact, it's down to about 1/100%. And then you got what's called the Great Oxygenation Event, which happens about 2.4 billion years ago. And the oxygen goes up to about 1 or 2%, then it drops back down. And this is a period where we don't have good data, but we know that the oxygen content was less than 1%. So what caused this to happen? What caused it to happen is what you see in Genesis chapter 1, creation day 3. Let there be continents. This is when God transforms the earth from being a water world to where you now have continents and oceans coexisting. And we now know these continents appeared suddenly, and the sudden appearance caused the oxygen content to go up by what's called the deep oxygen cycle. You can read all about that on our website. But what happened about 580 million years ago, the oxygen content jumped from less than 1% up to 8%. Now, what I'm going to show you is an experiment that was performed by a team of physicists back in 2018, and it got published a little bit later. And so they basically take the known constituents of Earth's atmosphere, put it in a big flask, and they vary the oxygen content. And so when it's less than 1%, this is what the atmosphere looks like. Okay, totally hazed out. You can't see objects even 100 feet away. Totally hazed out. That's the whole of Earth's atmosphere when you got that little oxygen. Then as you gradually push the oxygen content up, and by the way, the fossil record tells us it jumps suddenly to what's called the great unconformity. You've taken geology classes, you've heard about the great unconformity. Massive landslides off the continents into the ocean that drove the deep oxygen cycle and jumped the oxygen content up very quickly from less than 1% to 8%. But what the physicists did in the lab is basically say, okay, what happens as you bring the oxygen content up? So you bring it up and you actually get to see something that's very faint because of the haze. Actually, what I got here, I simulated their experiment with a photograph of a mountain that's a third of a mile away. So you can now begin to see a bit of an outline of that mountain, and it gets clearer and clearer as the oxygen content builds up. And here it's at 8%. And now you can actually see something in the sky you couldn't see before. And that's what you see in creation day 4. The sun and the moon become visible for the first time in the sky to creatures on the surface of the earth. If you want to read about this, every week I put out a blog called Today's New Reason to Believe. And it's a June 18, 2018 article where I talk about this. And I also talk about how we actually see the oxygen content jump up to 8%. What happens when it hits 8%? You immediately have the Avalon explosion. From here back to here, all you got is microbes. If you've got less than 1% oxygen, that's the only life form you can have on the face of the earth. But as soon as it hits 8%, it's now possible to have animals for the first time. And what do we see? We see animals as big as 2 meters across, and they all show up all at once. There's no time delay. They immediately appear in a wide variety of species, but they don't have digestive tracts. They don't have a brain. There's no circulatory system. There's not enough oxygen to support animals like that. They're driven to extinction, and then 543 million years ago, the oxygen content goes from 8% up to 10%. Now we got enough oxygen for animals with circulatory systems, with digestive tracts, with brains and eyes and internal organs. And this is what's called the Cambrian explosion of life. And what we see in the Cambrian explosion, new phyla show up, and they all show up at the same time. And the phyla show up before the classes show up, before the orders show up. The exact opposite of what you would predict from a non-theistic perspective. You get the phyla first, and you get the genera and the species later on. And even the most complex phyla, the ones that were part of the chordates, they show up right at the beginning of the Cambrian explosion. In the words of Richard Dawkins, these animals come out of nowhere with no evolutionary history. And they all come up immediately, including even the vertebrates. And this represents the oxygen content going to 20%, which is now enough for birds and mammals. Okay, I'm going to switch from the life sciences, and hey, my colleague, Fazal Rada, has written numerous books on the evidence. In fact, his latest book is what's called the biochemical anthropic principle. Because just like Hugh writes books on the anthropic principle in cosmology, there's an anthropic principle in biochemistry. Matter of fact, we have plans to bring out a book on the anthropic principle in every single discipline of science. It's there, it's ubiquitous. But one thing you're going to see in my new book, Designed to the Core, is that for the first time, we've been able to define what a super galaxy cluster is like, and what and so this is a super galaxy cluster we live in.
So you're transitioning from one discovery area.
Yeah,
to
we're
another.
going from,
Okay,
yeah.
let people know where you are.
This is discovery number 3 that we're dealing with. Yeah, and believe it or not, we've been through 2, so now we're into number 3. Okay. This is the super galaxy cluster in which we live, the Laniakea super galaxy cluster. And what was a shock when astronomers produced this map just a few months ago is it's different from every other super galaxy cluster in the universe. The other super galaxy clusters could be envisioned as being like a basketball or a football, where you got tens of thousands, hundreds of thousands of galaxies jammed tightly together in a spherical shape or a football shape. The only exception is the one we're in, where it actually has the shape of, say, a stick insect. If you ever looked at a praying mantis, very thin creature with these long, spindly arms, this is how the galaxies are distributed. Now you say, well, where are we in this whole system? Well, let's zoom in a little bit, and there we are. That's us. And what you notice is we're in the least populated part of the Laniakea supercluster. We're actually the juncture of 3 subfilaments of the Laniakea supercluster. And this is where we get exactly the heavy element abundance we need that keeps us far enough away from nearby giant galaxies that we don't get disturbed, and far enough away from big black holes, which pour out deadly radiation. I mean, this one right here, for example, is filled with really nasty black holes. We're far enough away. That's not a problem for us. Moreover, as you look at the black holes in the Virgo cluster, their jets are all aimed away from us. They're aimed this way instead of this way. And by the way, the jets move with respect to time. And right now, they're pointed away from us. In the past, it wasn't the case, but now they're pointing away from us. We're living at the one moment where it is safe to live. Okay, but we not only live in a super galaxy cluster like no other, we live in a galaxy cluster like no other. I'm not going to talk about that, but we also live in a grouping of galaxies like no other. We live in the only grouping of galaxies in the entire universe where there are no giant galaxies. In fact, there's only 2 medium-sized galaxies. This is ours, the Milky Way, and over here we have the Andromeda Galaxy. Notice how far apart they are. We look at other galaxy groups, the big galaxies are close together. We live in the only grouping of galaxies where they're far enough apart. Far enough apart where we're not going to be gravitationally disturbed by the Andromeda Galaxy. And then we got a bunch of small galaxies. We've got this one here. This one here is actually the 3rd biggest. And that actually plays an important role. And then we have a super massive black hole in this galaxy. It comes in at 140 million times the mass of our star, the sun. And normally that would make our galaxy uninhabitable. But right now, it's in a super quiet phase. We're in a window of time where the black hole in the Andromeda Galaxy is quiet. If you go back 100 million years, it wasn't quiet. But we're in a window now where it's quiet. And likewise, we have a supermassive black hole in our galaxy. But for the size of our galaxy, it's by far the smallest supermassive black hole. It's only 4 million times the mass of our star, the sun. And we know of no other galaxy of our size that has such a tiny supermassive black hole. Moreover, as we look at the radiation coming out from it, we realize it's in the quietest phase it's ever been in the history of our galaxy. You say, how long can that quiet phase last? Well, probably we're looking at a few 100,000 years. We humans are living in that narrow window of time when both the supermassive black hole is quiet and ours is super quiet. And so advanced life is possible. And then we zoom in, and here we see our galaxy, and we see the large Magellanic Cloud and the small Magellanic Cloud. As you look at our galaxy, you see that it's unlike other spiral galaxies. The arms are highly symmetrical. They're spaced just the right distance apart. And the galaxy is big enough that it doesn't get bounced around by encounters with other galaxies. If it was any smaller, our spiral arm structure would be disturbed. If it was any bigger, it would make a much bigger black hole and we'd be in trouble. It's just the right size. However, it would not maintain this spiral arm structure if it weren't for these two galaxies here, the third and fifth largest galaxies in our local group. They're just the right distance from our Milky Way galaxy, and they're oriented with respect to one another in such a way that they act as a funnel, feeding much tinier galaxies into the core of our Milky Way galaxy. You cannot sustain spiral structure unless your galaxy is consuming dwarf galaxies at just the right rate, just the right size and just the right rate. And what makes all that possible is the fact that we have a large and small Magellanic Clouds acting as a funnel, feeding these tiny dwarf galaxies into our galaxy and sustaining the spiral structure. We got an astronomer back there. He's got a question. Yes.
Recent research shows that the Andromeda galaxy and the Milky Way all are like merging together.
Right.
What do you want to say about that?
Okay. Yeah, this is not a permanent situation. We now know that the large Magellanic Cloud actually is about 8 times more massive than what we thought. We used to think it was just the 4th largest. We now know it's much more massive than the triangular galaxy that you saw in the other thing. So massive, we know it's simply a matter of time before the large Magellanic Cloud merges with our galaxy. And when that happens, it's not going to be pleasant for life here on planet Earth. On the other hand, that's not going to happen for 4 billion more years. So in terms of your investment portfolio, it's safe for the next 4 billion years. But the Andromeda galaxy, likewise, is moving towards us. Even though they're so far apart, we do know that their merger event is coming. When will that happen? Somewhere between 4.5 and 5 billion years from now. Of course, when that happens, the sun will already grow to such a size it'll incinerate the Earth. So, yeah, this world is not our home. This is not the permanent habitation of humanity. We know that bad things are going to happen in the future, and we're talking a long time in the future, but I can tell you this, it's not going to be that long before the sun is too bright for photosynthesis to be possible on planet Earth. Say, when is that going to happen? We're going to start losing our food crops within just a few million years. So you need to put that into account in your investment strategy as well. Okay, but in terms of our galaxy, our Milky Way galaxy, it has to have exactly the right diet. If you don't have our galaxy consuming dwarf galaxies, the spiral structure collapses after 3 or 4 rotations, and you wind up becoming a highly collapsed galaxy. Most of the galaxies in the universe, indeed, are those highly collapsed structures, and now you've got the stars too close together to have stable planetary orbits, and too close together for there not to be deadly radiation. And that little yellow dot there shows you where the sun is. But what I want to show you in the next slides are the 12 spiral galaxies that we astronomers have found that come the closest to matching the features of our Milky Way galaxy. So look at our Milky Way galaxy here. You can see these highly spiral, symmetrical spiral arms. Also notice there's not a lot of stuff between the spiral arms. Not a lot of feathers, not a lot of spurs. But here are the 6 of the 12 galaxies that come the closest to matching our Milky Way galaxy in terms of their size and spiral structure. But what you see here in every case you got a spiral structure that is disturbed compared to our Milky Way galaxy. Not so much disturbed. Some of them might be candidates that have microbes existing on them for 1 million years or so, but none of these are candidates for advanced life. And here are the other 6 that come the closest, but none of them come anywhere close enough to being a candidate for advanced life. How many have ever seen any of the Star Wars movies? Okay, you all know they all begin with a little panel that comes up, a galaxy far, far away. We astronomers have looked at galaxies far, far away. None of them are candidates for advanced life. They need to rewrite the script. It's got to be our Milky Way galaxy. Moreover, it can't be all over the galaxy. There's only one place where it's possible. This actually shows you where our solar system was born. That's important that it be born at this point. At this point, you get the highest density of heavy elements, and to have a strong magnetic field and plate tectonics, we need to be on a planet that's super endowed with heavy elements. This is the place where the heavy element density is the greatest. However, if we stayed there, there'd be no possibility for advanced life. Notice how dense the stars are. You're going to have issues. But what happened was when our solar system was really young, it had a gravitational encounter with supergiant stars that basically kicked us away and had us settle into another place where it encountered supergiant stars and settled in right here. So what is this big annulus that you see here, that red annulus? That shows you what's called the co-rotation distance in our galaxy. The distance from the center of the galaxy where the spiral structure rotates at the same rate that a star would revolve around the galaxy. But you don't want to be exactly at the co-rotation distance, because if you are, you get what are called mean motion resonances. I'm not going to take the time to explain that. That'll all be in the book that's coming out. But the best place to be is just inside. If you're just inside the co-rotation distance, you only cross a spiral arm once every billion years. Last time we crossed one was about 500 million years ago. So right now we're in the safe zone between 2 spiral arms, which is the safest place for advanced life. And I'm going to end with this. This is something I talked about yesterday, published just a few months ago. And this is the recognition that early in our solar system's history, the sun was pouring out a much stronger intensity of particle radiation. Such a strong intensity that is challenging for a planet that is close to the star of the size of the Earth to retain its atmosphere and its hydrosphere. These particles of the sun basically erode away the atmosphere and they erode away the hydrosphere. And until a few months ago, it was thought that Earth's magnetic field was strong enough to be able to prevent our atmosphere and hydrosphere from being eroded away. But a paper was published, and I've written an article on this on our website. You can see all the citations, basically making the point how we now know that Earth's magnetic field would not be strong enough to prevent our atmosphere and our oceans from being completely eroded away into interplanetary space when the Earth and the sun were young. But the paper makes the point that the reason why it didn't happen is that there was 5 rocky planets in the early solar system. You had Mercury, you had Venus, you had Mars, you had Earth, but you had a 5th one called Theia. And Theia and the Earth had a collision event. But it was a low velocity collision. It was basically a merger where Theia merged with the proto-Earth, resulting in a bigger Earth with a higher density, more uranium and thorium to drive the plate tectonics and the magnetic field, but it also produced a big moon. Unique in astronomy is we're living in a system where we've got a small planet orbited by a single gigantic moon. And because this merger event happened early, there was a lot of heat release. What happened was Earth, after the collision event, had a liquid iron core, but the moon also had a liquid iron core. And you need that to have a magnetic field. But just having liquid iron is not enough. You have to have the liquid iron being circulated. You need a dynamo in order to get a magnetic field. And what this figure shows is that the latest model, the moon forming event, shows us that early on, you've got the moon and the Earth close together. This shows them just 18 Earth radii apart from one another, 9 Earth diameters apart from one another. Close enough together that the Earth's gravity pulls more strongly on the near side of the moon than the far side of the moon. And the difference in those gravitational pulls actually circulates the liquid iron inside the moon. And the moon did the same thing to the Earth. And so in both cases, you've got a dynamo in the moon and the Earth, and they're close enough together that the magnetospheres couple. And it's the coupling of that magnetosphere of the moon and the Earth that gave us a strong enough magnetosphere that prevented the early sun from eroding away our atmosphere and our hydrosphere. Now, the scientific research paper was published, it stopped right there. What I've done in my article is to add a few paragraphs making the point, okay? The only way you're gonna have long-term life on a planet is if you've got an Earth-Moon system like this, where they got a coupled magnetosphere. No coupled magnetosphere, you're not gonna have life on a planet, which means life is not gonna be possible anywhere else in the universe unless you've got a Theia Earth-type merging event, where you get an Earth that has enough uranium and thorium in it to generate this magnetic field. And you're gonna have a moon formed out of it. And you're gonna have the two of them be getting close enough together that they have a coupled magnetosphere. If you don't have a coupled magnetosphere of the required strength, there's gonna be no possibility for life on the planet, which is another piece of evidence for what's called the rare earth doctrine. You know, astronomers came up with this a little more than 20 years ago, the recognition that planets like the Earth with a capacity for supporting life other than microbes for a few months at a time must be extremely rare in the universe. And I can tell you since the year 2000, when the rare Earth hypothesis was first proposed, every year that's gone by, the rare Earth idea has gotten rarer and rarer and rarer. But the most spectacular addition to the rare Earth hypothesis was published just 6 months ago. And yeah, I got an article on my Today's New recently explaining everything that is there. Okay, I actually left quite a bit of time for Q&A on purpose.